Whoa, that was a quick cut. Let's try that again. Hold on, that was a bit too abrupt. Still didn't transition. Come on. Okay. Well, I guess that's gonna be it for for the starting transition. It's a bit rough. I know. Blurry. Yes, I know. So today we are not in the studio. Today we've got a bit of a different setup. This is my editing workspace, dual monitors and stuff. I didn't feel like standing today. And also this is my regular workspace because we are doing something that wouldn't make any sense in the studio. So we've got the potato webcam, the Logitech C170 up here, just on the stream because I'm not important today. My face is not important today, even though it's full screen. I know, 12 FPS, whatever, it doesn't matter. Because today we are doing OnShape. Why is it not transitioning? Why is it? Oh, it's on cut. Okay. Apparently I forgot how to use. That's better. Apparently I forgot how to use OBS Studio. But today we are doing OnShape. We are doing an OnShape design experiment, trial, whatever you want to call it. I mean, the idea today is not to be like a super complete, involved, complex design. This is just going to be a try run of how much we can do together in OnShape, in the cloud-based OnShape CAD tool. Because who put this like because eventually, like if you look in the video description, eventually my goal here is I sort of want to do a 1 day, full day stream, you know, starting in the morning today, in the morning 1 day, and finishing in the evening and having a full 3D printer design at some point during the day. And what I want to do is, you know, have you guys involved and be able to, first of all, look at the designs live and clone them or fork them, which would be the GitHub language, fork them and design your own parts and sort of submit them during the stream. We'll see. Why not Fusion 360? I don't know, tried Fusion 360 a while ago and it sort of didn't click with me. OnShape clicks a bit more though. We'll have to see. So to get access to this, this is mirrored. This is weird because my screen's like over here. Okay, to see this stream or this file that we're working on, you can go to the address in the address bar up here. It's also linked in the video description because OnShape has this model where if you're signing up for a free account, which this is, okay, I'm getting likes on this one already. If you're signing up for a free account with OnShape, all your designs are going to be public. They aren't exactly going to be listed like in a directory thingiverse like, but it is going to be public. So anyone with that URL is going to be able to access it and you know, clone it, use it for their own stuff, and you're not going to be able to hide your designs. That's what, yeah. 123 design. I don't know. I thought they were making 123 design obsolete or something. There's something going on, I think. But whatever. Today's going to be about OnShape. So if you want to, you know, open up this design, you can go ahead. Links in the video description below. So the other thing I want to try out today is what's going on here? The other thing I want to try out is, you know, having democracy, because it's, you know, in these times democracy is sort of a special thing. It's not really the an accepted standard anymore. But let's just try and do you know, everything. I guess it's like the CAD version of what's it called? Twitch plays Pokemon. You guys get to tell me what I do. So I'm gonna try doing polls through Nightbot. I think Nightbot is gonna be, let's see, if I say poll, Nightbot should, Ah, yes. Okay, so Nightbot is in chat, and I will be using Nightbot in chat. I will be using Nightbot in chat and setting up, I think it does straw polls. So that's going to be linked, and we are going to be able to see the results over here. Yes, SolidWorks is the best, but SolidWorks is also like 80K for a license that is going to be outdated in a year. So I don't know. Not making that much yet. Cool. Right. Now, let's start with democracy right now. So I put 2 suggestions in the title. First one was a fidget spinner, because those things are still popular, like after months of seeing them around. Fidget spinner, that's like idea number 1. Let's switch me back to the, ooh, that looks horrible. Let's switch me back to this. And yeah, first suggestion, a fidget spinner. We're gonna try and see what sort of design we're gonna go with. A battery holder, because I have a ton of AA batteries that are just loose, and the one that's on Thingiverse. SolidWorks can be free. Please, no discussions of pirated software or shady sources here. Yeah, battery holder, I have a ton of AA's, and the popular battery holder that's on Thingiverse just doesn't work. It just the batteries don't roll out as well as they should. So right now, let's start out chat. Let me know what you would like to see. There's a few suggestions. I'm going to type out the poll, and I'm going to fill that with your suggestions as we go on. So, poll, new, spool holder. Complete 3D printer. Yes, the complete 3D printer, that's what we're going to do another day. That's what this is the trial for. Spool holder, complete new 3D. Yeah, that's going to happen. So the tool things, spinner and battery holders are already set. Box with hinge. Okay, I'm just filling up the poll right now. Hinged box, new logo. I don't have. Do I need a new logo? Hopefully not. 3D printer accuracy test, battery spinner. Spool holder. Let's plop that in here as well. So, links are disabled. Let's actually see if this works. So suggestions are in. How live is this? Okay, so there is the poll. I feel like that process. So that again, this today is just going to be the learning experience. This today, yeah, might not go as smoothly. So I feel like having the suggestions right here and then plopping all of that into a poll. Maybe not the smoothest thing to do. Let's see. Coral vase. I should have added the vase there, but... Poll broken? What? Nah. Poll's working. Spinner is not available as a... Oh, okay, forget about that. New poll. Again, this is what the learning curve is about. So the first option is spinner, battery holder. Hold on, stop voting on that poll. Spinner, battery holder, spool holder. Hinge box. Okay. Screw democracy. Nope. Designs. No. What are you? Do I have to actually? Hold on. Don't go to that one either. let's design, yeah, in a second. What the? So poll new. Let's actually pull this up over here. Poll new. Then we're gonna have the title. So title is gonna be design. Then the first one is gonna be spinner. The second one is gonna be battery. The third one is gonna be spool. And the last one is gonna be, what else do we have? Box. Third time's the charm. Okay, there's the link. Let's click that. Spinner, battery, spool, box. There we go. That's what we need. I'm gonna give you guys a second to vote on that. I see Nightbot is doing his job. Haha. Yeah, so we do have Nightbot with us today. I do need him for the chat functionality, and he's also like, I know he's sort of aggressive with modding and blocking people, but you'll get used to it. You'll get used to it. And no, we're not voting for political parties today. Let's see. How do you vote? You click the thing. A panel that we can join together because of the size limitations of the printers. That is interesting. All right, it looks like a Nightbot posted a link for the poll. That is true. He should. Did he highlight me? No, the highlighting is just for me. Okay. So it looks like you guys are voting. I should mute my phone. I'm sorry about that. I guess people are what? There you go. Okay. What do I want to make? Well, democracy. We're gonna make up for that. So yeah, focus is out of whack. Webcam is just crap. So it looks like we're gonna make a spinner design. There we go. So can actually close this thing? I don't think so. But I can do something like poll results, I think. Nightbot, come on. Yeah. Results are in, spinner 47 votes, battery 38. So we are gonna make a fidget spinner. Now, the one core thing we have to keep in mind with the fidget spinner design is the bearing we're gonna use. Oh, can I actually show you guys my new tab history? I don't think I should. Oh, let me check what's in here. That's okay. That's all okay. You guys can see that. There we go. So now the thing is with these fidget spinner designs, so that there are a few different ones. Now you've got the one that is just, you know, super simple. Where is the one that I was looking at? But essentially all they are a bearing in the center. Typically this is like a skateboard bearing or something. Someone banned this guy. Block. I can block people, by the way. Oh, Simone, you were faster. Okay, thanks for that. So a few different designs that we have is, you know, just a simple one with a few weights on the ends. This one seems to be like really popular, just one bearing in the center and then 3 other bearings outside. And like I think these are sort of boring, but you do need that extra weight on the outside to make it a bit heavier, to give it a bit more what's the word? Weight. Yeah, inertia. That's the word. To give it a bit more inertia. So that's one option. The one bearing in center is going to need to spin really well, so I think I'm just going to take a regular skateboard bearing and wash that out with some thin oil to make it really easy to spin. Shuriken designs, unfortunately, are illegal here in Germany. Anything that can be confused for a throwing weapon is banned. So we're not going to... Okay. Right, angular momentum, yeah. So let's see. These are the designs that people have already made. Let's see what else we can do design-wise. So I've pulled up OneNote, and that's usually like the process I do for 3D designs in general. So, oops, switch screen. Nope, display toggle again. There we go. And why am I still on the? There we go. 4-leaf clover. Good idea. Good idea. Yeah, crab bearing, take the grease out, or wash the grease out. That is what I'm gonna do. Print it on the TiVo little monster. I'm probably not gonna need it that large. So what I usually like to do is start out with just a sketch, and I actually have ideas are coming into my mind. So let me know what we should design around this thing. I'm gonna start out by designing like a I'm hoping I'm getting these right. This right here, right there. And I have a cross like this. What are the other ones? Heart. Make a spinner that looks like my logo. That's gonna be incredibly boring. So 4-color deck. What are they calling that? So we've got the spade, we've got spades, clubs, hearts, and diamonds. Okay, so I'm guessing spades are going to look like diamonds a lot, so let's actually start out from that side and connect it like this. That's going to look identical, won't it? And then clubs on this side. That's like an idea from me. Very, very fragile. Okay, so idea number 1. Water waste, whatever. Hard to balance. We're gonna have to check that out. So idea number 2, bearing gear on the outside, and some relief cuts in here. This will be printed. We'll have to. Wow, I'm horrible at drawing this. This will have to be printed with a really, really high infill to give it a bit of weight, because I don't think we're going to be able to add any to it. Or maybe we can just add a few screws out here and weigh this down like that. You get the idea? World's biggest fidget spinner. It's obviously also down here. That's idea number 2. Gears. Well, Kevin, I don't think we were going to do anything useful today anyway, so... Right, diamond, that's not balanced, maybe. That looks like a propeller, bicycle sprocket, yeah, more or less. The 4-leaf clover, so... Let's see how we can visualize this. Okay, so it's got the heart-shaped things. Balance with steel balls, that's going to be really hard. Now we could make one, maybe just, let's see, so bearing the center, 4-leaf clover, but that's going to, no, that's going to have to be at an angle, so that's going to be here. Here, that looks like balls. There and right there, and maybe we can connect these and just like put a little dimple there to visualize it, and then have this one maybe flange out a bit or flare out a bit too to make it a bit stiffer, and then just do this times 4. I'm too lazy to draw that. Spin it with a planetary gear in it. I don't think I'm going to be able to make that today, because the planetary gears, we're going to have to use some sort of a generator for that, and we would have to import something into that. Different shape for each gear. Put some nozzles on it. That's sort of cool. Yin yang. Okay. how would we do that? So it would have to be one bearing up here, one bearing down here, another bearing in center, and then like this maybe, and then flare this out. I don't know how good that, well, this is going to need a bit of extra space up here anyways, but bearing in the middle of the clover, okay. So that would be, but then we have a stem somewhere. So stem right here. 1, 2, 3, 4, and then the bearing in center. Oh, that might work. I don't think the stem is going to add that much. What is this? Ideas for fidget spinners. Okay. There's our 4 ideas. All really simple parts. Dual colored yin yang spinner. Yes, that would have to sorry, that would have to be something that would need to be printed on the Ultimaker 3, for example. Quadcopter shaped spinner. So where's my pen? There we go. There's option number 1, there's option number 2, there's option number 3, option number 4, and option number 5. I'm just going to highlight the center bearing. 1, 2, my numbers are horrible. That's where it's going to spin around. So let's do pole new spinner type. Let's see if I can get it right the first try. 1, 2, 3, 4, 5. Nope. Why did it not pick up the 5? 5. There we go. Can I delete messages? Nope. Remove. Yeah. Cool. Use the straw poll to vote. Don't vote in chat. Poll 5. Does that actually work? Let's see what Nightbot says to that. Can you do poll 5? Don't vote in chat. Don't type out your answers in chat. That does not work. I think. Does it? Does Nightbot pick? I mean, it would be awesome if it did, but I don't think it does. Where'd my poll go? There's my poll. What is a fidget spinner? It's entirely. Will I print the winner? Yes, I will. I don't know if I'm gonna print it today. Maybe, I don't know. It's gonna be difficult streaming wise because this is. I would have to restart the stream from the laptop downstairs. Maybe we can do that. Let's see. Right. I guess I should just let you see what we're doing here. 1, 2, 3, 4, 5. Okay, so it looks like it is gonna be number 5. So yin yang. It's gonna be yin yang spinner. So this is going to be interesting because this is no poll to see. Yes, there is. This is going to be interesting because this is going to be, can I hide the pages section here? This is actually going to be a dual extrusion design. Chat votes work. That is awesome. So, make it more interesting. Well, I guess the dual extrusion design is going to be interesting enough on its own. I'm thinking about how to do this. Poll results. Yes, Simone, you can operate polls as well. I think there is documentation on the Nightbot. There is documentation on the Nightbot poll function as well. So are you banned? No, you're not. Most people don't have dual extruders. Well, I'm thinking, can we do this for a single extruder type setup and just cheat by swapping filament mid-print? I don't think that's going to work, but Oh well. Okay, so it looks like the yin yang symbol has won by a small margin. Make one half higher than the other. The only problem with that is it's going to be unbalanced. Dropping my Wacom pen. It's going to be unbalanced, so that might not be a good thing. We can make it two-part and gluing it together, but that would mean it wouldn't just be two parts. It would actually be... where's my webcam? There we go. It would actually have to be about 4 different parts. So we have the... why not just draw it? What am I doing? Screen cap. There's OneNote. So it would have to be a few different. Let's actually pull up a reference here. So yin yang. Okay. Well, it's like, I guess this is a correct one, but the one the one you obviously know is this sort of a design down here. Wikipedia, yay, that's like the Taiji. Cool. Wait, it's actually, oh, it's actually the Southern Korean flag. I never realized that. I learn something new every day. Cool. What about split half the two and connect them in the big side? Yeah, so we are actually gonna have to do, can just pull this over here. Apparently not, okay. We are gonna have to do what? A few different parts. So it's not just gonna be, Nightbot is a bot. Nightbot is literally a bot. There is no point in offending him. Oop. Let's do this black. So there is our circle, and this is going to be just an a. Right, so it goes right down the center. We've got this circle here, we've got this circle here, we've got these two right there, and then there is going to be a big fat bearing in the center. So unfortunately, that's going to break up the slant the sides from the bearing side to pointing. I don't know what that means, but yeah, we're going to have a few different parts. So obviously this is going to be one part to print, and it's going to be identical to this one over here. But this guy over here is also going to be the same color. So we've got one there, and then we've got the other parts right there. So that's going to be one color, one print. So this fish shaped object. The question is, should we do should we do a bearing or a weight in here, or should this just be a printed color? Again, let me know, chat. You decide. Can I make it clickable? Can I make it clickable? Can we actually assemble this like a puzzle piece? Wait up, we can, but I think we should still add a bit of a bit of glue to make it a bit more sturdy. Hold on. So if we actually connect the parts right here, just have this hidden, have this on the bottom or something, have it like that and like this. That could work. That could work. Cool. Snap fit, it's probably not going to be a snap fit. I can't guarantee that much. But it is going to be a design that sort of, you know, fits into each other without... Okay, that's going to work. So no weights. Well, we're just going to have to try and print it and see if we're just going to have to make some pockets like on the back here and add a few weights like hidden from the back or somewhere else here. The thing is, this is going to look good from one side, but it's not going to look that good from the other side. But let's just try it. Let's just try it. This is going to be sort of, yes, this is going to be sort of a dovetail shape, but let's see, put in AA batteries, yeah. Have a battery holder at the same time. So let me think. So the 2 pivot points. Covers on the other side. Yeah, so let's covers on the other side. Could we have this as a single printed part? Probably not, because then it wouldn't snap together. Are the colors going to be black and white? It's going to be two different or two individual parts. So whichever color you print them as, that's how they're going to turn out. So let's get rid of the Wacom here and start designing. So slot with a hole and a pin. So again, if you want to join in on the design process, I don't think you can. I can whitelist OnShape. OnShape designs. Well, we'll just see. Okay, let's start designing. But if you open up this exact document, which you can find the link to in the video description, you can see this thing coming together live. So what I usually like to do, again, I am no pro CAD guy. I just know how to make things happen. And usually that works out pretty well for me. What I often do with more complex designs is just make one throwaway sketch as like the starting point and then design everything off of that. So like right now I am starting out with just the base shape. So I'm thinking 60 millimeters is probably going to be a bit large, but it might be, hold on, so if we actually get this, nope, there. So 60 millimeters right there. If you actually get this, like, I mean, the idea with a fidget spinner is you hold them between your which side can actually show, there we go. You hold them between your thumb and your middle finger, and then you spin them with like the rest of your fingers somehow, so or index finger and thumb. So it is going to have to fit through this opening that your hand makes. So 60 probably is going to be good enough for not live and OnShape. I might have to actually confirm this sketch, so now it should update for everyone, I'm thinking. So 60 millimeters is going to give it a bit more inertia. Maybe if I, no, let's do 70. Simone is posting links. Let's see what that is. Hoping that is nothing too naughty. Oh, so that's a suggestion from Simone. Okay, that's, I mean, that sounds, that looks painful. Yeah, let's start out with just the basic yin yang design. Make it 70, right? And let's add a center line here. Now, OnShape works in much of the same way that you know, any other CAD tool works. It's very similar to Fusion 360, SolidWorks, whatever other CAD tool is. The way of thinking about your design, the way of making things happen is exactly the same in any other tool. It's pretty much just which buttons you click and should I make this mirrored or rotationally? I don't know. Which buttons you click, where those buttons are, and you know, just details. But in general, all the tools are pretty much the same. So that's the right side, left side. Let's cut this guy out. That was too much. Can I not cut this? Why can I not cut this? Let's try it again. Yeah, well, let's rotate this up and we should be good. So do a rotate 2x. And usually when you have like a symmetrical part like this, you can just design one thing, go through the entire part, and then rotate it afterwards. I just like to do it like that, because then it gives me a bit more of a visual representation. Come on, there we go. As we go along. So OnShape is still blank. Let's see. So if I'm gonna delete this extrusion in a second. If I extrude this with like 10 millimeters, does that show up for everyone? Does that actually update for people? This one's gonna be the whatever. I'm gonna delete it in a second, anyways. Okay, so that's showing up. Perfect. So undo that. Go back into the sketch. Are we still in the sketch? No. Top. Okay, so we are going to use a standard. Well, now it should have disappeared again. We are going to use a standard 608 bearing, which is, let's just look it up real quick. The standard skateboard bearing, 22 millimeter on the outside. Oh, let's actually look it up on the wrapper wiki. That is kind of cool. So 608, 22 millimeter outer diameter, 7 millimeters thick, and the 8 millimeter inner diameter. So this is going to be 22 and actually centered on here. And that's going to be our bearing seat. One like, well, if I probably have to refresh this thing to get it to show up. That's going to be the bearing seat. Now, that does not leave us with a whole lot of space for the circles inside the... I'm not going to try to pronounce that again because I'm just going to butcher it. For the yin-yang symbol. So yeah, but I guess this looks good. Let's actually step it down to 12 so that we get a bit of space and material left for the bearing. I am gonna make this exactly 22. Well, maybe 22.2. The one annoying thing about OnShape is that you have to use the dot for what we use as a comma. You do have to use a dot instead of the comma, which is sort of annoying, but whatever, we can work it out. Hi, Joe. By the way, I don't know what you're doing here, but yeah. Okay, so 2 halves. If only I had that multi-material upgrade already. I don't know. It would make printing this thing so much easier. Also, I could use a few new PI surfaces. Hint, hint. Right, there's our base shape. Now the only thing we have to do is figure out some sort of a connection over here, and that is gonna be... Well, it's not gonna be too hard. We just need some sort of a linkage, but I think we're gonna add that in later on. So 22.2, that should be enough to just glue the bearing in. We're not gonna require a super tight press fit because we're not gonna get that press fit. These parts aren't going to be super tightly connected together, and I don't want to put any super high strain on the connection here between the parts, because they are just going to be, you know, super glued together. So 12 right there. Let's start out with the first half, and for that, let's mirror this guy down. There we go. So that's pretty much the entire design. All we need is like one connection strand, and we're going to add that in later on. I could go with 80. Which would give me a bit more space. Let's try that. Now, the cool thing about, you know, good CAD, parametric CAD like this is, you know, you add your dimensions, you figure out like center points, and you can update any dimension, and it's not going to crash the document or anything. where's my calculus? Let's check that again. So 80 millimeters, that is pretty big. Let's see, and I have relatively small hands. I feel like 80 is too big. That's compromise. That's what democracy is about, right? Making everyone sort of happy. Cool, 75 should be good. And can you scale it? I guess you can scale it, but you do have to, you know, add or use a different bearing if you do that. But of course, you can always just fork this design on OnShape and scale it yourself. All right, so what I'm doing here, this is sort of cool with 688. I don't have any 688s. I only have these 608s, and the other bearings I have that would be like 6 millimeter inner diameter are sealed. That's the problem, that they are RS bearings. So the thing is, I'm not going to be able to get the grease out of them unless I pry off that seal, and sort of don't want to do that. So the cool thing about OnShape is you can just select areas in the sketch. So I selected this and that part. That's going to be 1/2, and we can just hop over to extrude, and it's just going to pick those areas. What was it, 7 millimeters deep? It's going to pick those areas and only extrude those, which is pretty nifty, I think. You do need that quite a lot. So that's that. Click. And that is our design. I mean, we're almost done here. So the one thing we're going to have to add is a connection from this piece to the other one, and add a matching relief cut on this guy over here. So let's show this sketch. I don't want it hiding yet. That's like the default behavior. Did I want this centered? No, this is good. This is like the default behavior. I guess you can assemble it differently. Die Unterseite des Halbkreises auf Unteroberseite spiegeln. What? I don't know what chat is trying to tell me. In the center of the thickness. Center pin connection. Well, I guess we could add like a snap buckle in the center of the part, which is going to be a pain to print. You can always go in and, okay, that guy's talking about nipples. I don't want that. I don't want to add any nipples to this part. Okay, well, let's just start out with the not seeing the shape in OnShape. It should. Well, that's why we're doing this trail run. I was hoping it would update a bit quicker, but I actually did try it beforehand, but whatever. Let's just keep on going. So right, let's think. So we've got the connecting bridge that I'm just going to be. I have to transfer these other elements here first. Actually, what we can do is just use these, and we can either pick the geometry or the sketch curves and just say, where's the button there? Use, plop, and now we've got these edges in our sketch, and they will update live when we update the geometry. So that's always going to be that's always going to match up to the exact geometry we've got in our actual part. So these two actually are going to be, hold up, construction, because I just needed the center point essentially. There we go, make that horizontal, and this one is going to be construction as well. And we are going to add a center rectangle right there. Make that 5 to give it a bit of strength. That looks good. Press P. Press P? Let's press P. Oh. Cool. Again, I'm no OnShape pro yet. I'm no full-time CAD guy. So like shortcuts have always been my weakness. I've never been like too great at memorizing all these different shortcuts that you just learn over the years. Actually, this is like in the very center, so actually this one, can I get this? Does that actually work? Hold on. Oh yeah, okay. Use the dots to lock the part together. Yep. 22.2 is too big. Well, the problem with actually, let's make this thing rather deep. The problem with 22.05 or 22.2 for the center bearing hole is it depends on your printer. Some printers like to print big, some printers like to print small. Like on the Ultimaker 3, I've discovered if I did like 22.0, the bearing would just flop in as like a perfect fit. The Ultimaker is really good. The Prusa Mark II is also really good at making accurate dimensions. But some other printers, especially if you have like the ripples from the individual segments, they do add a bit of, virtual thickness, whatever you want to call it, to the to your mating surfaces. So that's going to be something you just have to experiment with your individual parts. So same thing here. I'm going to add this bridge with 5 millimeters. Let's actually do this right now. Nope. If I actually selected the right thing. We're going to add this thing with 5 millimeters. We are going to add this. So this is sort of the same thing as in, let's make this like 4. The same thing as in the Autodesk tools, where you actually have one extrude tool that just does a linear extrude, and then you pick whether you want to add a new body, a new solid, whether you want to add these two and merge these with the rest of your parts, whether you want to make a cut, remove, obviously that would have to be the other way, and we're going to use that in a second, or do an intersection, and it's all the same extrude tool, which is different than what SolidWorks does. SolidWorks has an extrude, a cut tool, everything separately. Why is this guy blue? Parts will have to twist. They will not. Yeah, it's all these same. Are these? What the hell is going on? Yeah, it's the same tool, which is really cool, I think. And why did we actually create new body? I think we're gonna have to do a merge with all right there. So now it merges it with these with this larger part as well. Okay, there we go. Okay, that's the first one. Let's actually re-enable this sketch right here, so we have a reference for the cutout we're going to add up here. And let's sketch this again. I guess we could do it with the same sketch and just can I? What? Yeah. We could probably do it with the same sketch and just have two different areas, but whatever. So that's going to snap right there. That's going to snap right there. I'm thinking that's actually going to add the correct relations between these parts. And if we were to do this properly, we would add a variable and stuff. And like do one variable that is 5 millimeters and then just use that variable plus whatever clearance you want, but whatever, it really doesn't matter for today. So let's just do 5.1. That should be a good fit. Do another extrude, remove, Obviously, that's going to be the other way around. Do a, what do we have, 4? So let's do a 4.1 because like top and bottom surfaces. Well, actually, let's do 4.2 because this is going to be a bridge. So that's going to droop down a bit. 4.2, add a bit of super glue, and that's just going to fill it up perfectly. Okay. Boom, done. Basically, I don't want to make him equal. Yes, I could do that. But I do not want to because I do want to have a bit of clearance right there. How will I stop the bearing falling out? Super glue. So the idea right here is, you know, it is going to be a part that will need a bit of glue to hold everything together, including the bearing right here. These parts aren't going to mate perfectly into each other as well. So, well, I guess these are the exact same size. So we're just going to have to see. Right, let's make an assembly out of this. So I'm not too versed with assemblies yet. Just hit space? No. Shit. Not too versed with assemblies yet. I did do a few, but there we go. One, I think I should add a few mates. And I shouldn't hit escape. Part done. Okay. Let's try and mate this thing up. Route the edges first. Well, the thing is, the assembly is non-destructive. This isn't like a dead end. We can always go back to the part studio and modify anything over here, and it is going to mirror over to the assembly. So let's see if we can actually get this thing going here. So the way OnShape's mating or fasteners or whatever system works is you add these mating locks, more or less, and you add the mating lock on the other one as well, and that just connects them up like that. You can add an offset, whatever. I think we can reorient this like that. And there we go. There's our assembled part. And we should be able to see a bit of clearance right there at the connecting slot. That is right. Perfect. Let's see, can we add a material just for one? That would be cool. If we add a new sub-assembly, then we should be able to... Nope. Looks like you guys can print it today. Well, again, the design files should be online. So someone wants to see that done again? Well, let's undo it. I might have been we lost the second part. Why do we have? Ah, that's the sub-assembly. Okay, and that one's gone as well. Okay, let's redo it again slowly. I think I picked the entire part studio, so you can select individual parts. Just gonna place those. Done. We're gonna pick a fasten mate. You can add these mating connectors first, but if you just add the regular fastened mate manually, it's going to add them to the parts yourself. And you can already place these mate connectors in the parts themselves instead of just placing them in the assembly. So that's going to match up the centers of these bores, and then we can reorient the second axis. Now, theoretically, I guess if I were to pull this, do we have a rotating tool? Let's see. Can I shift alt? Nope. So these are, well, these are locked. Okay, so that they aren't going to go anywhere. But in theory, we don't have, at least in SolidWorks, that would be the case. In theory, we don't have these parts like fastened at a rotation yet. So these could still rotate, but whatever, it's not going to matter. The only reason we're doing this mate is checking if this thing actually fits together, and it does. Right. Okay, let's actually export this part. So let's start out rename. I did position the webcam quite intelligently. I'm just realizing. That's going to be yin. I would like to have a second part that is called yang, but yeah. And right now we can just do a export. Yin STL, oh, yang STL binary millimeters fine download, boom. It's downloading. That's going to open up in Netfab. And there we go. There is our ready to print STL. Let's actually pull this over into a slicer and quickly slice this guy. Now we could also download the assembly, I think, and slip through. All right, there we go. And have a, let's actually check this out. I've not tried this yet. Export. Can we yeah, okay, so we can export parts as individual files, and that should export them correctly aligned. But we can also export it as a single STL that's going to just have two shells in it. Angus talked about that recently, why two shells are bad. But in the case of a dual extrusion setup, you can separate these and actually print them as individual objects with a different color. So there we go, there's that. Add a bit of tolerance or the two parts will not fit together. I don't know. Well, okay, let's see. So the spots where they might not fit together is this edge right here. That's highlighting a bit too much. This edge right here. And this edge right here, obviously, and this one down here as well. Let's try something. Am I going to have a cover for the bearing? That is a good point. We're actually going to try and design one after this. So let's try something, because we do have a feature called thicken. That's move face, not quite. Modify. Where is our thicken feature? There we go, there. Thicken. Okay, we should be able to, okay. That would be a negative clearance, so these will collide. And we should be able to just invert this and say remove. Okay, that's not too elegant, but actually, I mean, I think this should work. If we just add a 0.1. And here you can see it's just deleting that tiny bit of material, and this edge is not going to be printed anyways. 0.1, that should be enough. That should be enough. Okay, there's that. And let's also negatively thicken the inside of this hole. Remove. Other direction, that is too much. That is definitely too much. Let's also do 0.1, so that's going to add 0.2 to the diameter. Cool. Okay, and let's check the assembly. And there we go. You can see there is a bit of space in here already. And there, that's like the most apparent edge of the part that you know, now has a bit of material removed. Now, what can we? A delete phase would remove that, but isn't delete phase just surface based? Whatever. So we could have also used thicken on the inside over here, and just done it with the same 5mm size essentially. But that's good. So people are wanting a bit of a. We're going to be printing this. I will try and set up the laptop downstairs for the print in a second. So people are calling for fillets, or actually let's do. What should we do? Should we do? I hope I'm noticing in time. What should I notice? It needs a twisting motion to a. Oh. Whatever, we're printing in plastic, right? I see what you mean. Because the okay, so we're not going to be able to just drop one on top of the other. This is good point. Good point. Good point. But I mean, come on, we should be able to assemble that, right? If we add, hold on, can we actually add a? Well, my Padawan's writing in Hangouts. Let's just tell him that, there we go. So, can we add a draft to this one? Well, I guess I should. Neutral plane, hold on. So, neutral plane will be that, and then draft this and this one. Oh yeah, but that's adding material. This is just to make this twisty thing a bit easier, but that's just gonna add material. I don't want to add anything. Thin the arm, put a hinge in it. Thin the arm. I mean, what I could do is add a big chamfer to these two parts. Equal distance. Let's see. H of x, y. What? Okay, 5 is not going to work. 3, 2. Why can you? I don't like that spinny thing. 1. Why can't you not chamfer this? What? What is going on there? It's like, ew. Nope, that's not gonna work. That's typically like fillets are gonna be a lot. What is up with that geometry? Oh, I see. Okay, so we've got, I guess this is from the thicken operation. There we go. What if this SolidWorks would have done this a bit cleaner? That's gonna make it nicer. Chamfer before thicken, yes, that will work. Actually, let's show that. So you've got this bar, the rollback bar, which is one of the, I mean, once you discover that thing, it's like, why have you not used this before? Rollback bar, and you can just insert features there. That is just, wow. That's just something that's going to be so incredibly useful so often if once you know how that works. Distance and angle, let's see if I can make this work. So 30 maybe. And let's do a 4. That should make it easier to assemble. Three. Cool, that's still gonna align itself. And now if you pull down the rollback bar again, and this thing is gonna have updated. Twisting motion to assemble. I think we should be good now. Maybe add a bit of a chamfer down here. Not that much, maybe. You really only need it on one side? Yeah. But I'm lazy and I don't want to think right now which side that would be. That's not 15, that is a 75 I want. Perfect. That's gonna make that easier as well. And let's just, okay, this is a bit dirty and it's not gonna work either. Are we, there we go. Still a bit of an edge, but that's much better. Oh. Hold on. What is going on with that chamfer? So we do have this little lip from the thicken operation. That's this one. So let's actually get rid of that chamfer and add it right here. Distance and angle 75 and 1. Better. Okay, so thicken should apply to this one. Perfect. Okay. Now that should be enough to, make it assemblable. Assemblable. Is there an adjective for that? Cool. Cool. Let's check the assembly. Assembly is still good. All right, now obviously we do have these openings on the back. You can always add like a small shim, like a decal or something there. Move face. Okay, next design I will use move face instead of thicken. Cool. Got this done. So this is, let's download it again. And this is ready to print. Let's actually print it again. Or slice it at least. So let's check netfab again. There we go. So orientation is good. Size is mostly correct. And I mean this this end right here, this is going to get rounded over by the slicer just by the nozzle size anyways. So we are good there. What's up with my mouse? Better. Won't work out too well as an actual spinner. Well, we're just going to try out. We're just going to try it out. Cool, Slick 3R. Yin. There's our part. And we're just going to print one because the second one is going to be a different color. What's up there? Oh, this lip's not going to matter too much. Yeah, I mean, the great thing, that's Hoffman Engineering saying, the great thing about 3D printing is you can just try it and see how it works. It might need some additional mass. I mean, we can go with a high infill or pyramid. It's probably not going to matter. 50. Let's see how much material that actually gives us. Probably more than enough. Let's see. So that should be okay. That should be okay. Now, interestingly, I expected it to take off much more of this point. Okay, my face is in the way. I expected it to take off much more of that pointy area back here, but yeah, I mean 0.4 millimeter nozzle is still pretty small. So no support material. No, we don't need any support material. The only thing that is, sort of critical is this area right here, but that is a perfect little bridge, so that's not gonna droop too much, and we do have a bit of clearance. Prusa released a new version of this slicer. Crap, I must have missed that on social media. Cool, so that's, I mean, this little lip is not gonna matter. Not gonna matter. Export G code. Export it somewhere where it actually syncs over to the laptop. $133.5. I will need to upgrade that. The second with full info. What? Whatever. Okay, that's that part done. I'm not gonna start the print right now, but let's actually go on and design a quick. Because I mean, this is just a really simple part. Let's actually just design a quick center finger hole thingy. What that's called. So for that, we are going to use a rotation. Let's see. So we are going to have the bearing, but the bearing is just going to be. Well, I guess once we start gluing stuff with super glue, it's not going to matter if we have the center part actually just screwed together or something. Yeah, let's just make that fitting and then glue it together. So for that, we are going to use a rotation. So rotation needs a center line. That's nope. Okay. There is dust in my mouse. Rotation needs a center line. Center line is usually construction, or is always construction. And for that, so we've got an 7mm bearing. So that first lip is going to be 3.5. Then a little lip to, why is this? I don't want these to be construction lines. Thanks for that tip, by the way. A little lip so that it rides on the bearing's inner race, and then a little cut so that we're not dragging along the rest of the bearing at the surface. So that's going to be the surface that's going to be against the printer's bed. Let's see, so theoretically, once we add the first dimension, which we're going to add over the center line and just make it 8mm, yep, it's going to scale the entire thing down, which is something that SolidWorks does as well. SolidWorks introduced like 2 years ago. If you don't know about it, in certain situations, it's like super annoying, but whatever, you get used to it. The center bearing 8.5mm hole on one side and push the bearing in from one side. So use something in the middle to spin it so the hole in the middle is smaller? What, Steven? You can turn it off in SolidWorks. Well, I don't think I'd want to turn it off in SolidWorks because it is a really comfortable feature. Let's make that 4. Let's actually make that entire thing. How big are my fingers? I mean, I guess looking at the style caliper, that gauge there looks like a really comfortable size, maybe a bit too large. So let's actually make it 30mm. Cool. And because we've set up this shape, so if you've not done CAD, this is going to look pretty magical. If you can actually pick the what. There we go. Boom. Entire button done. Just with that one profile. Cool! Make it the same as the bearing. I don't know. I'm just going to make it a bit larger to make it more comfortable. What we could actually do is... well, it would have to be a 2-part design to create a little dimple in here, but 30 feels and looks good. What we can do, because this is when we're going to be printing it like that, we can add a small chamfer right there, 45, so that, and this surface is still going to seat against the bed, and then that the rest of the part is going to stick up. Make it look like a middle of the yin yang. Ooh. 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 You guys are giving me ideas. So, haha. Now, what we are doing here, let's actually bring out the Wacom again quickly. Shit. Wacom. Where's my OneNote? So, what we can actually do, so we have the big yin yang. So that's that. And then we have the button in the center, which is going to be pretty large. We could add this line to the center button, or we could just make it another yin yang symbol. like that. I don't know if that's going to look good, but if you just add this line to the center, that would actually look pretty good. Let's actually do that. Make a V-groove. How do we do a V-groove? A V-groove is going to be difficult because we don't have an angle that it... V-groove would be a, well, essentially a, what is it called, sweep. A sweep operation where you have a profile plus a tool essentially that carves out that profile. The problem is the tool needs to be perpendicular to the profile's line, which this is, hold on, this is horizontal, so we could do that. I mean, if we, I guess we can just, yeah, we can cheat and just do a linear extrude, linear cutout, and then add chamfers to the bottom to fill that back in. That would work. So put the weight of the pierce constraint and sweep it. Okay. Plane normal to the line. So yeah, the center, this line right here should be like perfectly vertical in the center right there. So let's actually add the, should we just add the bearing for funsies? I think we should. Kyle Fodder is using why I don't use my router. So the if I don't, why I don't use my router there, the Mental Max converted part. Hold on, guys. I need to concentrate here because this is radial ball bearings. That sounds good. Then 6 deep groove basic. Yeah, but we're gonna have a 2Z in here. Cool. This catalog, again, this is one of the apps that you can add. That doesn't look like a 608. This is one of the apps that you can use to, get parts for OnShape, and 3DX. It's a bit tricky to use. Is that a 608? That looks too fat. I guess we're good here. This is one of the apps that you can add, and it's just like, it's an incredibly useful tool just to have all those standard DIN, ISO, ANSI, whatever you want, from all the different manufacturers. There is a shit ton, a metric and imperial shit ton of parts in here, and I mean that's just awesome to have. The only thing I've sort of can we do this right here? No. The only thing I've discovered with this particular part catalog is that the parts you're getting are not always properly constrained. So if we add this thing, let's say, okay, this is just going to come apart. These are not constrained together. So that might be something that, well, the catalog provider might have to fix beforehand. I think how we can fix this right now is just to add a new subassembly, then go into that assembly. That's the assembly 2 over here, and I think we can fix all of these in place, and that should nope, that does not. I had this figured out. Hold on. If we fix these, is it going to be fixed in the assembly? Yeah, crap. Okay, anyways, we could add this bearing right now. If anyone in chat has the solution, I'm not capable of recalling it right now. Need to add the assembly and remove the parts? What? We already have the assembly in here. This was moved to the sub-assembly. The assembly is still there. Use fast and... Oh, that's the part again. Crap, assemblies. Assembly 2. Let's get rid of these. You need to build the assembly and pull the part from that assembly. So we've got the assembly here, but nope. Boolean button, we don't need one part. We first mate in the toolbar. So all of these are going to go with a fastened mate. And I'm gonna have to fasten these individually. First mate button in the toolbar, yeah, but in the bearing sub-assembly, okay. That's the assembly, so that is good. Fixed, these are already fixed. So right now I can't pull these apart, which is weird to me. Why can I still pull these apart? I had this figured out. I will need to look into that. Let's just say at a later date. So let's get rid of the bearing again. Hold on, can we... if we group these, are these not fixed in the assembly? These are not fixed in the assembly. Can't group these. Okay, let's just get rid of the entire assembly. And I mean, we're not gonna see the bearing anyway. So actually, let's rename this guy before we insert it. So you guys are saying that's called the button. Assembly number 1, insert button right there. I would like to see it snap in place right there. But wishful thinking and all. So in theory, we should be able to, yeah, there you go. We should be able to just select this edge, and that's going to place the mate connector at the exact edge of the bearing. Then we're going to be able to select this edge because this is circular. And this is going to fit it exactly where we want it, and then just flip this thing. And yeah, that should be pretty much perfect. Save the assembly as part? No. Keep the assembly as an assembly and then use the assembly in the other one. Cylindrical mate? Yeah, but I had something figured out where I would just have to... can I mirror this? Well, should we mirror this? Yes, we should. I did have something figured out where we wouldn't have needed any particular mates from one surface to the next. Just select the entire thing, fix it in place, and it would be good. Can we mirror these parts? Circular. It looks like that's still missing. Replicate? What is replicate? No. Okay, let's just add another one of these. Someone was asking why I didn't have a fillet, a rounded edge right here, but instead used a chamfer. The problem is when this surface right here seats against the printer's bed, if you look at it like this, if you add a 45-degree chamfer, the chamfer is just going to be 45 degree. If you add a fillet, so a round over, it's going to be basically flat on the bottom. That's going to be an impossible to print overhang. It's not going to stick well. It's going to look ugly, and it's just going to ruin the rest of the rounded part up here. So this is just going to curl inwards. It's going to create this awkward ridge. This part up here is just going to droop down, and it's not going to look that great. So fillet usually works pretty well there. So Let's mate this guy up again. Start here. That doesn't look right, but it works. 1, 2, okay. Let's see if we can I actually edit this part in here? Edit in context. Cool. So we should be able to just use. So these are usually the situations where you run into really big issues with like context and consistency inside a document, and that's where you can really easily just mess up. We need a sketch. Mess up a document if you have too many recurring self-dependent sketches, etc., etc. All right, can I extend this guy? Ooh, yeah, I can. Cool. Extend that up to here. Trim this away so they meet. And this is not where we wanted it. Oh, we managed to get the one that's offset. That's not what we wanted. Well, actually, let's keep these. Context of assembly. I mean, OnShape does a whole bunch of stuff already. There are a few things still missing. Especially if you're comparing it to something like SolidWorks, of course. But, I mean, for the most part, for like the maker style user, it is, you know, everything you could want pretty much. Okay, where's our trim? There's our trim. We can split these. Let's just split this guy over here somewhere and this guy over here. That's split. That's split. So now we can get rid of this part. Oh, crap. Last design is a bit dirty. Where's our fix? Can we? There's our fix. Let's get rid of this part, and then we can just trim off the fat. I keep looking for these tools because now it's a split tool. Okay. Now we can trim off this part and that part, and we should have a bunch of construction lines. Now this one, yeah. That's not construction. What do we do? Holy crap. It's also not construction, and we need to get rid of this little part right there. Okay, now we're good. Now we're good. What a mess. Yes, this did get really messy really quickly. I would like to apologize for that. Also, this is not correct, but whatever. It's just a decorative part anyways. So we should be able to do a thin feature surface. Nope. Do this guy. Let's see how this works. 1 millimeter deep. Other way around. There's that, and then we should be able to add a thicken. Haha. Again, let's see how well the thicken works here. 1. Nope. 2. Thicken. Remove. direction 1 is going to be 0.5. Direction 2 is going to be 0.5 as well. And that is going to create our yin-yang channel right there. Perfect. Actually, make it a bit wider. Make it a bit wider. Make it 1 and 1 so that our chamfers will look good. One millimeter chamfer here, there, here, there. Cool. We could have left it just as a slot, but yeah. We could have used a sweep. Yes. Where is it? There we go. That would have required us to add a second or create a profile right there. But we should be okay here. Okay, button is sliced. Let's get rid of the surface right there. Delete that and that. Do you have to delete the part? Oh, the surface is apart. Okay. There we go. Now these edges are going to be a bit critical for overhangs and stuff, but we should be good there. Button is single color. If you wanted to, if you had a dual extrusion printer, you could use that that exact surface right there, cut through the entire part and print it with 2 colors. Oh, okay. Cut through the entire thing, print it in 2 colors. Or we could just cut it apart, print 2 different colors, and print it like that. But for now, we're just going to leave it like that. And if you check back with the assembly, that does line up on the other side. It is not quite lined up. Can we mirror these parts? We cannot, but you're just going to have to trust me for now. We are going to print one of these mirrored, and it is going to line up on both sides. We actually designed this on the wrong side of the spinner. Okay, that's that. So let's actually go back to Slick 3R. So that's our. Well, export the button first. By the way, those of you who have the design open in OnShape, are you seeing these updates in real time? Can you dig through the design and see what I'm doing here? Or is this all just wishful thinking? Button 1. I'm sure NetFab has like a hold on, that wasn't what I wanted. Mirror, there we go. Gonna be button mirrored. No updates real necessary. The interesting thing though is I had the that is weird. I had, let's actually check this. I had the design open in 2 different windows, and it updated perfectly fine whenever I did something. So for example, if I roll this thing back here, that is instant between the two windows. That is like absolutely instant. I don't know if that is, you know, just something that OnShape doesn't do for like shared designs that were shared through a link. But for me, it is absolutely instant. Same user and browser, yeah, but it should be different threads. Anonymous user, can you actually program space variables? I don't think it does. It's different tabs. It should be a different process. Can we do? Where is our anonymous browsing? Can you tell how often I actually use Chrome? There we go. So let's try that. That should give us an idea. Control Shift N. Okay. So that was something interesting. I was seeing the so I'm getting a totally empty document here. I'm getting Assembly 1 and Part Studio, but there we go. There's the live preview, which is what? So I'm getting the correct previews for the assembly and stuff, but I'm not getting this thing updated. Hold on, so if I, wait a second. So if I go in here and links, where'd that share button go? Where did that share button go? Come on. Share, oh, now it says share, okay. So anyone with link can view, all OnShape users can view. Does that update anything? Oh, I have to block someone. Yep. So let's see, anonymous F5. Okay, Hoffman Engineering is seeing the parts correctly. I will need to get in touch with OnShape about this one, because this could be pretty much a I'm slowly creeping out of frame for the webcam. Sorry about that. Oh, now it's updated. Okay, that is interesting. I will need to investigate into that a bit more. I can see. So with the anonymous tab right here, I can see the button right here. I'm gonna have to talk to OnShape about that. Okay, or I just regularly click that share button, which would suck and be totally unintuitive. Okay, right. Part number 1. Someone was asking, hey, is the Slick 3R slicer better than Simplify 3D? I don't know. Prusa's Slick 3R is free, Simplify 3D is not. I guess that makes it at least $149 better. And for me, Slick 3R does everything I needed to, plus you get like profiles and stuff for everything. I'm not seeing the need for Simplify 3D too much. Well, I'm sure some people will have a few features that they really want, but I'm really happy with just using Cura, Simplify 3D, Cura, Slick 3R, and yeah. So far, I managed to print everything I needed. I mean, cool. So that's that. We are printing at 0.2. Of course, there's the bridges. Really simple parts. I mean, export G-code. Let's see. So I will need to switch over to the stream from the laptop, which is probably going to be a bit tricky with you guys can see the update in OnShape, which is going to be a bit tricky with the YouTube streaming setup thing. We'll have to see. Actually, before we do that, let's check how long this is going to print. That's like, Prusha, if you're still here, Joe, the one thing I'm missing about Slick3R is previews for, or predictions for how long a OBS Studio, for how long a print is going to take. Where did I save it to again? Shit. For how long a print is going to take, and like the code from gcode.ws is like really spot on. Just today I had a print that was predicted with 4 hours 12 minutes, and it took 4 hours and 11 minutes. So this thing is going to take 1 hour 32 seconds. I guess it would be pretty simple to just add that same functionality to Slick3R. Cura does it too. Cura does it really well. So yeah, Cura 15 or Cura 2? Cura 2. Hands down, Cura 2 is awesome. I need to print the part twice. I do not, because I will need to print I will need to print it on a different printer. And shit. And being able to print with being able to delete parts with the actual delete button on the keyboard. That would be like a feature request. Maybe it's already implemented in the 1.33 version of Slick3R, of Prusha's Slick3R. So we're actually going to save this as young. Nope. Reprint yin and young. Cool. So that's exported as young. Run 2 i3 Mark IIs at the same time. Yes, I will do that because I have to. I have 2 machines. Cool. Right, so the stream will go down for a second. Will I do an AMA on Reddit? What? I'm not popular enough for that. Cool, someone already started printing it. Part-time Ronin, why are you mod? Also, Mega Making, why are you mod? You guys are patrons, so you are sort of trustworthy, I guess, and it's better to have more mods than not enough. So, yeah, more power to you guys. No, I did not mod someone randomly. I know these people. I know these names. I remember them. Okay, so it's sliced in Slick3R. Slick3R, that's what it's called, because there is a 3 in the name. If you're not seeing it, there is it's spelled SLIC3R. So it's Slick3R. Someone raced Tom to the finish line. Well, I mean, I would have to print it with 0.35 to really push it out fast, but yeah, right. I will put the stream on to... What's the best place to start? Well, I have a YouTube channel with about 200 videos. You could start with those. I'm going to put the stream on hold for a second, and it will go offline for a second. It will go blank for a second, but yeah, I know the 3 is supposed to be the E, but The stream will go blank at some point, but it will be back with a camera on the 2 printers printing this entire thing. So, right. It's going to take a second. What? I'll be right back. Don't be worried. You will see this thing printing. See you in a second. By the way, well, I guess since this is like the end of like the official part of the stream, thanks everyone for being here. Thanks for watching. Check out the YouTube channel, subscribe, check out Patreon, use the affiliate links, whatever. But the stream will go on. Mods can't ban mods. But yeah, stay tuned. Don't leave. I know like 50% at least will leave, but we'll just have to deal with it. Okay. Hold on to your balls. This is going to be really sketchy. So I'm thinking the camera should work.
I swear to God, your name.
Okay. One second. Again, this is really sketchy. YouTube Creator Studio. Where's my live stream? I need my live stream. I need my controls. Creator Studio. There we go. And I did realize that OBS Studio has already crashed on the streaming on my desktop PC. So I guess the stream was gone for a bit. I don't know. Events. So this is one camera on a tripod with the capture card plus the microphones from the laptop. Overlay chat not there. Yes, I know. I'm working on it. Someone's asking about affiliate links. Yes, affiliate links should work with apps as well. Open chat, a new window. OBS studio mode. So that I can edit this stuff without it. Okay, so the super chat is going to be screwed up in this version of cool. On my setup. Okay, let's get the tripod level. This is crooked. That's better. So we need like the following things. I'm not going to be able to read chat, I think. Okay, so we're going to need the following things. We're going to need 2 push ITV Mark II. We are going to need a bit of filament. We're going to need some black filament, which we already have loaded here, and we are going to need some white filament. That is flexible stuff. Okay. PLA to be exact. So we've got black dust filament loaded there. This is hips. I don't want to use that. Well, let's first get this thing off the table. So as you can see, I was working on the Mendel 90. I didn't lie to you earlier. This thing is coming together really nicely. Like fraction, like Eagles. Thank you, Eagles, for these. Just the carriage is so massive. I can actually pick this guy up on the crossbeam if I wanted to. Just really, really massive. The way I like it. Okay. This is still in frame, that's not good. Let's get this shoved over a bit further. Okay. Let's start over here. We're going to start with the longer print. Are my power cords long enough? Barely. Is that a frame? Should be. Oh, that is perfectly in frame. Cool. Audio is really weird. I know it's the recentral has stopped working. Is the camera still going? Yeah. I know it's the built-in microphone from the laptop. It's Lenovo software. It's not as crisp as it was before. I do acknowledge that. It's more or less just to have audio. I don't have the time to set up the Zoom H4 with a shortcut mic or anything down here. This is just what we have right now. So we're gonna print yin on this one. Man, I should really set up some octoprint setup with these. Okay, I'm hoping this is. Oh, look, there's still some stuff from the earlier print on here. I've got a ton of things with this glue stick. Yeah. Yeah, no, I've not upgraded you. That should work. And let's get the other one. This one's actually in the heated chamber, so we will need to. We'll need to something. It's a good thing that you just have these, sitting around. Just you need one, you grab one, you use it. That's the one with a hole in the PI. And what filament are we going to use for that one? Actually, let's go with. I don't know if I'm offending any. Yeah. I don't know if I'm offending anyone by using specific colors, but I guess Korea has red and blue, I think, on their yin yang. So if I use purple with this one, it should be okay, right? So for anyone asking how I use the filament rack, that is exactly how I use the filament rack. Why not print it all in one print? Because we're doing two different colors. SD card. What do I think about the CR10? I don't know. People have said don't do stuff or don't do business with. Let's try that again. People have said don't do business with GearBest. So I don't know if I should do. Take a look at the CR10. So I'm hoping you're able to, pick up the printer noise in the background. That's like the only reason why I have this microphone right here. Banggood is selling it. Oh, it's like, who do I prefer, Banggood or GearBest or some random AliExpress seller? Do I believe there is a market for cheap RepRap Ultimaker style printers? Is that a trick question? That is probably like 95% of the market right now. Cheap, low quality, RepRap style printers. That's what people are buying. These guys are. I mean, Prusa is selling a bunch of these Mark IIs, but compared to the amounts that like all the China manufacturers are selling. That's nothing. Wow, I do have the Z height dialed pretty well in this guy. When am I doing my cheapest possible printer? When I have all the parts actually. So let's see, there are a few parts back here. So I have the linear rails. I have the heated bed, which actually is just a 1.6 millimeter aluminum PCB. It's totally crappy. I have sensors, hot gears, bearings. But what I'm still waiting for is a RAM spool. I'm waiting for a genuine RAM spool. I'm also waiting for what else? One other thing. Yeah, wiring set. RAM's wiring set, which was like $3.14 for 14 3D printer wires. I'm waiting for that because I sort of want to use it. Let's actually not crank this guy up that high. I sort of want to use that, and yeah. Again, when I have all the parts, then I'm going to be able to do the as cheap as possible 3D printer. I might need to order a few things from German eBay. The problem is, just use white. I don't have any white. Well, I do have some white. I do have. Let's go with that. Yeah, I might have to order a few parts from just German eBay, where like a wiring set is 13 euros versus $3.14 including shipping. Which is insane, and I'm really not ready to pay that much. But like, I think I don't really want to just drag it out another month reordering some parts and waiting for those to arrive. Nope. Was that load? Okay, that was load. Any plans on reviewing the TiVo Tarantula? I don't want to get any more into TiVo on this stream right now. I will be making a nice script on the entire TiVo topic. I'm still trying to figure out what to think of the entire thing, so can't really comment on that right now. So yeah, encourage that a bit more. It's still sort of purpley. Let's just load again. Someone was asking, hey, how well is the Mark II doing for flexibles? The Mark II is doing okay for flexibles. It's not super great, but it does print flexibles, just not super fast. There is a profile included in the SlickVR that Prusa is making, which is rather slow, but that is sort of expected for flexibles. It doesn't print flexibles as well as like the Festus 2 extruder. That thing was awesome. Or the Flexion, that is also a really good extruder for flexibles. Yeah, Prusa average. But usable. I mean, you can print flexibles, it's just going to take a bit longer. Wow, that camera slide. Almost like it was done on a slider. Haha. Is V-slot extrusion better than having smooth rod? Depends. crappy V-slot plus crappy wheels is going to be worse than having smooth rods. But V-slot is just so much stiffer than regular 8mm rods. For some designs, it doesn't really matter. Like this guy is doing pretty well for just using the 8mm rods. For X, it sort of doesn't matter. These are just going to see static loads, so this might droop. For the Z-axis, I think that's where it would make the biggest difference. But like, I mean, for a well-tuned design, it's not going to make that huge of a difference. Polymer bearings, I did make a video of that. You guys want to see a close-up of the right printer? Get ready. The PEI bed looks rough. Yeah, I do have glue stick on there to protect it when printing PET and flexibles, because PET and flexibles will stick extremely well to PEI, and you know that's going to be just the end of it. So I sort of want to protect what's left of this PEI bed. So I can actually grab this camera if I don't yank out the HDMI cable. Holy crap, this is sort of sketchy, but there we go. So there is our first. Let's actually set this to auto exposure. And set the ISO to auto. So I don't have to worry about that. I'm already worried about focus. So this area in here where you've got the center bearing and the 12mm part from the other half, essentially, this looks pretty skinny. Is it actually going to... I think that's all the material we have. We'll have to see if the bearing can actually back that up enough, or if that is going to be an issue. So the other one, that's a bit too deep. Just going to adjust it upwards a tiny bit. If you adjust it too much, it's going to separate the layers. So yeah. So I've got, yes, who was that? Someone was asking if I'm seeing any differences between the two printers. No. There is so little of a difference that I would be seeing between these two printers that essentially I set up a better mic. Do I need a better mic? I don't know. But yeah, there is so little of a difference between these two printers, even if there was a difference. But again, I'm not seeing any sort of. I've tried it because I'm printing Halloween tests on both of these, and they perform the same. Benchies look the same. It's they are practically identical. The one difference that these machines have is, I don't know if you can actually see that. Yeah, I mean, better mic would be nice. I guess it's a bit of a jarring difference hearing the nice close-up shotgun mic, etc. versus this, but you guys are fine. Stop being so whiny about everything. I don't think you can see that. Well, sort of back here, there is that. Now the autofocus is working. What the hell? Back here, this little orange part. This is a backing part for the. This is a backer. Actually, the one to the right. Whatever. That is a backing part for the Y motor that the kit comes with, but the assembled one, the other way around. The other way around. One of these was the assembled one. That came with that spacer. That other one didn't. I'm not seeing much of a difference. It might just be in how much you can pre-tension the belt, but yeah. Blender is asking, can I use the camera mic through the capture card? Yes, I could, but that's worse. That is way worse. You don't want to hear that. Do you use them for different materials? Yes, I do. Better mic would be nice. I don't have a better mic. I'd have to get the zoom and then wire myself up, and I don't feel like that right now. Thanks for the tips, by the way, guys. Am I using these pushers for different materials? Yes, I am. One of them has a coated nozzle in them, a steel-based coated nozzle. Not a heat break, because the heat break sort of got everything jamming. Both of them are still using the genuine E3D heat breaks. One of them has the hardened nozzles for all those carbon fiber reinforced materials that I've been using, like Rigidinks Carbonite, Matter Hackers Nylon X, Proto Pastas, carbon fiber reinforced PLA. That's I've been printing all of those on that same printer with the hardened nozzle, but yeah, other than that, they are both still stock. I do want to keep one of these completely stock, completely unmodified, and use the other one as sort of like an experimentation platform and do things to hot end, extruder, electronics, whatever, as we go along. Good source for the when and what is next Halloween. So the question with Halloween, I guess right now I don't know how many people are watching. Let me check that. But I'm guessing we've got 378 people. I guess we've got the hardcore fans here. With Halloween 411. Holy crap! I don't know. Oh yeah, that microphone does sound bad. I'm sorry for that. The question with Halloween is, are there any suggestions, and as far as how I should improve the format? Because right now I feel like it's a 1 minute. Well, I've already started modifying one of these, so no point in deciding which one to leave stuff. But the format with Halloween right now is it's a 1 minute short video. It covers the same topics. It covers a very basic set of parameters of the material, but it's like not an in-depth review. And I'm feeling like when I upload a video, the expectation is that it's going to be like a 12-minute, fully scripted, fully edited masterpiece each time, and just getting that 1 minute video might be a bit disappointing. So there are two different types of things. Yes, there are. What I'm thinking is just, instead of like releasing a regular video, then a Halloween video, then a regular one, and like alternating them, I just do like 3 Halloween episodes, release them on every Thursday or Friday or whatever, and then bundle them up as a once per week package, and not as like an excuse of not making a full video during the week. Overall, rate them out of 10. Yeah. So the thing with Halloween was the the thing with Halloween is I didn't know what to expect when going in. So the first two materials were what I'd consider average ABS and average PLA, and it turned out they were actually, compared to all the brand name filaments, they were slightly below average. But that was my only baseline. I didn't have any measurements for all the other filaments yet. So giving one 8 out of 10, and then having one that performs better, and then having another one that performs even better would have been a dead end for me, because at some point I would have run out of just the rating scale, either on the top or on the bottom end. So I mean that they are getting that 18 out of 20 quality rating and the whatever out of 128 strength rating, which I guess is sort of the thing you're looking for. Difference between $15 PLA and $21 PLA? Well, one of them costs $6 more. Difference number one found. Have any filaments received my seal of approval? There will be an intermediary. Let's recap everything we've learned so far episode on the Halloween series, in which there will be a few filaments that will receive the seal of approval. So yeah, that is just because I didn't have a baseline understanding of what the ratings were going to be on average. I just didn't want to go in and start handing out Halloween approval badges left and right, because I would have to give them out for every filament that has the same level of performance. So yeah. Yeah, so question is, can you put a flexion extruder on the Mark II? Yes, you definitely can. Let me grab one if I can find it. Oh, it's right there. Look at that. So, flexion extruder, obviously that thing is made for the MakerBot style MK extruders that you would find on Malian printers, or what are the other ones, the genuine ones? Can't remember, but MakerBot style extruder. That's what this thing is, and it's not like a direct mount to the Mark II. None of the other extruders really are, but you can definitely print an adapter. You do need a heatsink for that. So yeah, if you can get that, just a standard heatsink on here and a fan, you can definitely put that on there if you make like an adapter plate or something. Like every stream is someone's asking for how to pronounce my name. Have I done a video on different print beds? Yes, I have done a video on different print bed surfaces, toppings, a while ago, called something like "Are Commercial Build Surfaces Worth It?" And I do still need to follow that up with a video on household bed surfaces, and whether or not they work and how well they work. Yeah, so again, these beds, if I wipe these off, if I actually grab a wet towel and just wipe this thing down, these look like new. This one has a hole in it, so don't worry about that. But these beds are pretty much like new. The PI on them is, but I have a ton of glue stick on them because I do want to protect it when printing PET. Am I planning on doing a video on the ANET A8 or ANET A6? Again, same question that comes up every stream. I do answer it every stream. I think it was it GearBest? It was GearBest. They promised me an A8 3 months ago, and just now they were like, I'm sorry, we're now out of stock. So I was under the belief that I would be getting an A8 for the last long time, for the last 3 months, and it turned out I wasn't. So yeah, I was planning on reviewing that thing, but it's like it might be a while until that happens. So one good question was, do I think that the Halloween results are repeatable by others? So the tests are specifically set up to be like super simple to print and super simple to reproduce. I don't think we should be having tests that are a black box and nobody else can reproduce and double check. I don't want to say that somebody else would be getting the exact same numbers that I'm getting, but for the most part, if you grab the same printer and the same default profiles, you should be getting pretty much the same results. And that's one of the reasons why I've picked the Prusa i3 Mark II for those tests, because it is a common printer. It is a very it's a common printer. It's just a very normal printer. It's not like anything that's super exotic or something. It's just a printer that works. The East has the best printers. Yes, I can confirm that. Prusa's lab is about 2 or 3 hours east of me. I can confirm the best printers come from the East. No, just kidding. There are others who are making great machines as well. Will I do a video on the Eagles filaments? Yes, I have like 10 packets of them here. The only problem I have with them is they are said to smell crazy bad. So, yeah. Have you ever let others reproduce your results? For Halloween, yes. So I did make I do have a post up on Tom's 3D. I think it's is it toms3d.org/Halloween? Probably. So there are the methods for how I'm printing this stuff. There are the files linked. The files are also made in OnShape, so you can download them and print them yourself. And my methods aren't the secret, which is the entire point of why I'm doing it. It should be somewhat reproducible and somewhat settled in the real world. And yeah, anyone can print it. Yeah, I don't think anyone has, but probably. Also, like the idea is, the concept of Halloween is to have, again, real world performance numbers things. If I were to do this super scientifically, then I wouldn't be using like a luggage scale to test the strength of these things. I'd be using something entirely different. But I know these tests aren't 100%, 1000% scientific and accurate, and accurate, reproducible to the last digit, but they are good enough to like give a good classification of the filaments and to tell which one is better than the other. And I deliberately didn't pick tests that looked more scientific because I didn't want to create the illusion of these things being more precise or more scientific than they actually are. Why is MakerBot hated everywhere? It's not because of their machines. Well, it sort of is because of their machines too. Um, if you have a replicated dual ripoff, you don't have a MakerBot. You have a MakerBot clone. Um, but MakerBot is sort of disliked because of their business practices, which do trigger a few people. Personally, I don't think they did anything wrong. Legally, I don't think they did anything wrong, but morally, maybe they did a few things that were questionable. So, yeah. Again, it's always those things whether you are allowed to do something and whether you should do something. So, yeah. Do you put things like this on Thingiverse? Yes, I do put some things on Thingiverse. I do publish more things on Umagine. But for example, like the slider, which was the last video's topic, I think that's going to go up on Thingiverse as well, just because, you know, my goal with these designs is would you employ to make about no never. My goal with the designs I publish is like to make life easier for as many people as possible. That's like the slider and the glide cam design and stuff. And you know, if I have the chance to do it, maybe throw a few affiliate links in there, and you know, earn a few dollars that way. But if I design stuff, why keep it under wraps? Why keep it, you know, for me only when other people can use it as well, and don't have to do the work all over again? So yes, as much as possible goes up on Umagine and on Thingiverse. Weren't I employed by MakerBot to MakerBot? No, I was never employed by MakerBot. BQ did hire me for a while, which was pretty much a year ago, pretty much exactly a year ago. Um, and and that didn't go so well. They didn't hire me for 3D printing stuff. They did hire me for education. But again, that's over. Matthias, what? Hold on. What? What? Matthias, I'm sorry about that. Nightbot seems to be really aggressive today. Hold on. Let me check that. What's going on there? Nightbot. I think Nightbot might have confused that for a YouTube link or something. 1 second. Oh, so channel is a blacklisted word. That is interesting. Because people would be like spamming, "Hey, subscribe to my channel, check this out," and then move on to the next 10 streams. How to deal with the issue that designing stuff takes way more time than printing? For me, it's actually the other way around. For me, it's actually most of the time, unless I've got a live stream going about it. Most of the time, printing takes much longer than designing stuff once you're sort of experienced with 3D design. So for simple parts, taking an aluminum plate, drilling a few holes in it might be easier than printing the same thing. Yes, this is a fidget spinner. Tech and Life is asking recommended settings for Tallman T-Glaze. Let me just check. Yep. Prusa Slickfire has a profile for Tallman T-Glaze, so maybe use that. Maybe use that. What? It won't let you open the shared document unless you pay for premium? What? Yeah, so prediction on this part was 1 hour and 30 something, so it's gonna be like another hour um, until these finish. I think I'm gonna have some cake uh, and then come back, yeah, in 45 or 50 minutes to assemble everything once it's done. Free subscription only allows editing of public documents. Yeah, this is a public document. Yeah, cake and a nice tall glass of milk with it. It's 8:40 p.m. here, so yeah, about right, about right. All right, guys, I'm gonna leave you to the sounds of these 3D printers, and we'll be back in 45 or 50 minutes, and then we're gonna try and assemble this thing and see how well it spins and how well it works. No printed cakes. Do I drink any alcoholic beverages? Usually not, but probably especially not on stream. All right, guys. Thanks for being here. We're gonna see each other in 45 minutes. Should get you like a bit of a better angle here. LCD should be in frame. These things should be in frame. Cool. Bit of a mess around here. That's what happens when you spontaneously prop up two printers to get them to get their Prince live streams. But whatever, we're good. This edge here might curl a bit, but should be okay. That's not gonna work. Okay. I don't know how loud I should be making this. Is this royalty-free music? No, this is Monster Cat. Monster Cat FM. I just opened it up in the browser and edit it there. Just a little bit louder. Yeah, I guess when I'm talking, the music kind of drowns out. And a little bit more. Ooh, first one's done. Okay, so sort of what I want to do here is first of all, take that thing off the platform once it cools down, but also grab a bearing and wash that out and get the grease out of it. So let's reposition the microphone. Like if the laptop's music microphone gets too annoying, I can always switch over to the H friend, which I grabbed. That's not a friend, but whatever. I can always switch over to better mic. So this one is still hot, so just gonna leave it. And the first layer was the nozzle distance was a bit too tight. The first layer was a bit too tight. I was printing some ASA before, and this guy just had to stick, so I did lower it a bit too much. Oh, that's autofocus! Yay! Yeah, we'll need to ask Pusha for one of these fancy multi-material upgrades. So, bearings. Standard skateboard bearing. Well, cheap skateboard bearing would be probably more accurate. And I've got this jar of ominous liquid. I use these to keep like acetone baths and that sort of stuff. And I think that this is not labeled, which is not a good practice. If you have like random solvents in a jar, please label them. But I think it's acetone. It smells like acetone, so I'm just gonna wash that out in here. And then re-grease it with a very light oil afterwards. Where do you get the ball bearings? The ball bearings are available on AliExpress. For example, on the link in the video description below. Just search for 608 and it's going to bring up like a 10 pack for 60 cents or something. These things are extremely cheap. German music? No, it's Canadian music. How do I estimate the print time? Use gcode.ws. It's a great free webpage. Yeah, and of course, if you just need these standard bearings, any skateboard shop is going to have them. Any skateboard shop is going to carry skateboard bearings, but there are different requirements for what you need in a skateboard and roller skates, etc., versus what you need just for these sort of cheap as hobby parts. And also, there is a lot of snake oil being sold when it comes to these skateboard bearings. Actually, do you guys want to see this? Frying, so glue sticks like really well. Actually, I think this scraper is that's about perfect. Yeah, so this one has quite a this guy has quite a sharp lip on the bottom. This is just, again, because I had set the first layer a bit too low, aka way too low. Yeah, but it should still work. What's up with the music? People were asking for music, so also I got one of these. This is a deburring tool with like these swiveling blade, which are sort of okay, sort of great for these outer edges, which are impossible to clean up with just the regular razor knife or box cutter knife. But they are made for metal, for aluminum and steel, so they can be a bit aggressive in plastic and sort of just eat into your material a bit too much. Also, this was like the cheapest one on AliExpress that I could find. It was like $1.23 or something. So, you know, I wouldn't be surprised if like the real deal works a bit better. Why is the audio so bad? Okay, that's it, guys. That is it. There's like one thing you guys can complain about is bad audio, and I agree. Stream's only gonna be like 30 minutes, but we got the totally overkill wireless lav mic, because why not? Okay, this goes here, here. USB. It's looking pretty great. Audio input, connect. Oh, now it's okay. Now the music is gone because it's playing through the H4n, which is always a pleasure. I'm thinking maybe the mic has changed too. Well, we'll see. We will see. Let's see. So, okay, music is definitely gone. Default. Okay, there is the music. And there's the H4 microphone. I hope that sounds better for you guys, and I hope you're happy now. I hope you're happy now. Audio levels seem to be a bit out of whack. Let's see. If I speak loudly, then it shouldn't clip. Okay. So yeah. Audio is a little low, yeah. It looks like it's a lot better now. So, okay. I'm just gonna talk quietly and a little light on the mixer. There's something wrong? I don't think there is. Static? Noise? Oh, noise. I mean, I guess we have the printers in the background. But the audio is still on? It's not. Actually turn this down so it's like not that irritating. That was the Zoom H4's built-in noise suppression, which is just a really ugly noise gate. Okay, should be better. Yeah, I mean, the printer is on quiet mode. The microphone just really likes to pick it up. The thing is that the laptop mic has noise suppression and everything built in, so it will filter out that sort of stuff and just leave the the stepper motor noises. But with the clip-on mic, you are getting pretty much unfiltered audio. So don't be surprised if it does sound different and if the printer is being picked up a bit louder than before. Am I clipping? Okay, let's turn this back down. I might have been a bit hot audio level wise. Actually, let's also turn down the compressor so that the printer doesn't sound as noisy. Cool, so I think we should be... Okay, so that was the compressor. Let's just turn that crap off, we don't need that. Okay, now it's clipping. Okay, let's turn it back down. Clipping is horrible. Cool. So that should be better. Okay. 50. All regular settings. Okay, now we should be good. Now let's take a look at that bearing. I mean, if I step outside, it's going to be, a lot quieter. That should be just, much better than right in there. I'm hoping that the music does help cover it up a bit. Sorry about the headphone, guys. I'm gonna get the Prusa multi-extruder color upgrade. I'm gonna have to ask Joe for that. I think. Oh shit! These. The problem is these tweezers. I don't think are resistant to acetone. But yeah, I think sooner or later I will be. That looks used. I will be getting the Prusa multi-material multi-extruder upgrade, and I'm looking forward to testing it. It's like, yeah, but Prusa didn't invent it. Yeah, of course he didn't. Prusa didn't invent the Prusa either. He didn't invent the 3D printer. He just made it great. That's the, that's the difference there. If you have a product, you're the only one who has a functioning version of it, then maybe you are doing something right. That is nice and sticky. So let's see. That's pretty much there. Let's just add a bit of like really thin oil. I mean, you could go ahead and just take off the cap rings over here, or the lids, the seals. These are not seals, these are just caps, essentially. Yeah, this is pretty good. This is pretty good. Good enough for now. Were these printed with 100% infill? These were printed with 50% infill plus 3 walls, so rather low, well, rather high for a 3D printed part. This thing is, it's a bit heavier than usual, but not really. Can I do more E3D videos? Yes, that is also part of the reason why I'm investing so much time in the Mendel 90, because that is also going to be a test bench for all things E3D. So I think this is kind of public. I do have one of the lid sinks, which is the Titan extruder with a heatsink built in. If you have a keen eye, you might have seen it on the Little Spot Mini in a few of my last videos. I did have it on there and we're using it. That's going to be on the Mendel 90. I will be trying out some of the 0.15 millimeter nozzles that they started making. Again, those do require a geared extruder, aka a Titan, to work, and that's also and also a really high precision. What's the autofocus doing? Also a really high precision linear motion system. Autofocus, come on. Blah. Really high precision linear motion system, which the Mendel 90 has. This bearing looks properly used. Holy crap. And yeah, I mean, the Mendel 90 is just going to be the machine for all of that plus some more. Okay, that bearing has seen better times already. I don't know where I got that from. It might have been some sort of a belt idler on one of my machines. Do I actually have some sort of general duty oil? Nope. So, German version of the low viscosity, not really lubricant oil WD-40 replacement thing. Ballistol, essentially a gun oil. It does sort of jam up over time, but as long as it's still liquid, it's pretty good. So the idea here is this bearing. Doesn't the Mendel 90 have problems with the Z-axis? I don't know if you've seen my Mendel 90, but I mean, I wouldn't call it a Mendel 90 anymore. It's, you know, it sort of looks like a Mendel 90, but and it's based on that design, but it has very little to do with what the Mendel 90 design is. So yeah, the idea here with these bearings is not to lubricate them and to take care of them. It's just to, you know, get all the thick grease out of them and make them as light running as possible. So essentially, if they were completely dry and just had a bit of really thin oil on them, that would be ideal. And that's exactly what we're going for. So we don't want any thick grease or anything in here. Yes, if we were to use something that was, or if we were to use a grease that was a bit thicker, like lithium grease, etc., this bearing would be much better for longevity and for actually taking up loads. But all we want right now is a bearing that sort of runs smoothly, and we really don't care about bearing life because we are just always going to stay below that minimum load, so it's not going to wear out whatever you do. It's just going to, you know, it's going to be perfectly fine. This is, I mean, the problem with this bearing, I think, is it's already a bit worn in. If you look at the inner race, there is already a good bit of wear, and well, a good bit is maybe a bit of an understatement, but this isn't the nicest bearing, but it's still like really smooth, so we're okay there. Should be good enough. Why does this camera not autofocus? It does. When I do the E3D tests on a Prusa, particularly stuff like dual extrusion, I do have a Cyclops and a Cyclops and Chimera. That's what they call it. I do have those. I want to test those. The problem is the Prusa only has a single extruder board, so I would have to swap out the entire electronics. Also, for the 0.15 millimeter nozzle, just the resolution of this direct drive extruder is not enough. This is okay for 0.4, This is okay for maybe 0.3, but 0.15, it's just totally not up to the task, and will cause some serious resolution. Look at that fit. That's actually pretty good. That is actually a pretty decent fit, I'd say. And once we add the second half, we're just gonna glue this thing in. And I'm hoping that these two halves will actually fit together. It would be hilarious if we actually printed something that we couldn't assemble. Spin it. It's gonna fall off. That's the thing. Yeah. So open source printers. Where did my chat go? There we go. Reviewing open source printers. I mean, this is an open source printer. The dice. I don't. Is the dice actually completely open source now? I don't know. I'm gonna have to ask René for that. The thing with open source printers is, first of all, they take a shit ton of time to build, to review, and to tune in. And there's like, not one version of that printer. It's sort of hard to judge a machine when you don't have like the definitive one version of that thing. So yeah, again, if you build an open source printer, everyone's going to build it 8 bits differently. So you're not just going to have one machine that you're looking at. You're going to have, whichever many or however many people built that machine, and they're all going to build it to their own spec. And I would too. I would also build the machine to my own taste, to my own likings. So that's hard, first of all. Second of all, I don't know if there's much of a point of reviewing an open source. Well, open source sounds like we're talking about the wrong thing here. So I don't think there's much of a point in reviewing like community sourced do-it-yourself kits, because like what is a review? Well, I guess it is sort of a guide in whether or not you should be buying something, but then again, you can make pretty much any printer a great printer if you put enough time and investment in it. And I don't think there are like any open source or do-it-yourself machines out there that are like horribly bad. As soon as they have a following, as soon as they have a community behind them, there is something to them. There is something to those machines that makes them unique and that makes people like it. Also, that there's a lot of printers out there that fall in that DIY category. So it would be like really hard doing a comprehensive review on each of them, and it would also be pretty harsh towards the author, because what should you be expecting from a DIY machine? It's already something I'm getting a lot of shit for when it comes to the TiVo machines. TiVo guys or the TiVo fans are saying, yeah, but like you're using the wrong scale. You are expecting a fully functioning printer, which I am, because it is a commercial product, but they're saying it's that the TiVo machines are not. The TiVo machines are supposed to be a DIY basis, and the manual sort of sounds like that. However, their sales ads don't. So I don't know. It's hard. I do want to build a dice at some point, definitely. Yeah, auto bed leveling is gonna get an updated version sometime soon. So we're at 96%. I'm gonna get the super glue. I'm really hoping we're gonna be able to fit this thing together. I mean, looking at the bearing and just checking how well this thing runs right now and how well or how much weight this is going to add, I think it's going to spin. I think we're going to be able to... look at that. Wow. Shit. I mean, that's what I was expecting, but look at it. I mean, it's spinning. It's totally spinning, even though it's going to fall off. Yeah. It's spinning, guys. It is most definitely spinning. What kind of oil do I use on my bearings after you apply acetone to it? Yeah, again, I was using Ballistol, which is not really the greatest oil in any way, but any oil that is like super light for this sort of stuff is going to work. I spun it. Yes, stay tuned for more. We're at 98%, so this should be done really quickly. Soon. Maybe. Breaks the part before finishing. PLA is actually, and that's something you're gonna see in the what kind of super glue will I use? Well, super glue. Stuff is all the same. Like the one conclusion from Philoween, because you guys have been asking about the Philoween series early on, the one conclusion I can draw from Philoween is PLA is actually not a bad material. PLA is hard. Yes, it's not the most ductile material. ABS is much softer than PLA, but when it comes to like raw strength, PLA is actually incredibly good. When it comes to just how much force it's going to take to break apart, PLA is excellent. So, just dropping this stuff, especially, even this tiny bridge right here, this tiny element here, that's not going to break easily. That's a bit rough. Okay, so these are done. These should pop right off if you get this skirt out of here. So, nope, still much too hot. Prusha, if you're still here, don't watch. This is not something you want to see. Oh yeah, these parts are still plenty soft, but let's get them out of here. Okay, so there's our part. We are victorious. So how does perspective work? So we've got two parts and they look kind of gay, which is not what I was going for, especially because we've got like black on white going on here. But yeah, two parts printed. Shit, I'm never gonna unsee that. So yeah, so two parts printed. Let's see if we can make these fit together in the way they were meant to fit together. Oh yeah, look at that. Look at that! Holy cow, that fits so well. That is like super satisfying, guys. Okay, it's gonna need a bit of force to click together. Yay! Look at that! It works! Let me get the hammer. Well, actually we have something hammer-like here. So the lip down here, this is what's keeping them from fitting together well at the moment. But I have these rubberized tools here. Yeah, that's good. That low rubber mallet, yeah. Whatever. Okay, so there's the back. There is the back. Come on. There's the back. So that's not going to require any super glue to fit together. I should have removed the burrs on the bottom here a bit better, but I mean this is just not coming apart. I like that a lot. Let's try the bearing. Okay, that's in frame, and that actually fits really well too. Oh, look at that! Look at that! I'd call that success. I'd call that complete triumph. Oh yeah, let's see if these fit. These are actually with a 0 tolerance fit. That's actually the correct side. Look at that. And this one fits too. Okay, this one is a bit loose. I don't know how do you spin these? I can spin these perfectly with the other hand, but nice. So no glue. No glue between these, and the bearing also has no glue at all. This side fits well, but this one is going to get just a tack of super glue to hold it in. It looks like it's a bit too long too, but by the way, just a tiny dab of super glue and we should be good here. I've not used this one before. This is like a fancy new super glue lid. Okay, and apparently that lid likes to dispense quite a lot of super glue. Okay, but thankfully that side is not going to be the side people are seeing. So, there we go. All done. That's that, and actually let's realign this one to match up. There we go, first side. Perfect. First side right there, that's the top sides of the prints. That's the bottom sides of the prints. Obviously this did pick up a bit of super glue, so glue stick, so we might be able to wipe this down and give it a good finish as well. And yeah, that spins. I don't know how you're supposed to use this, but I guess you can just sort of, I'm no fidget spinner guy, but I'd say this spins reasonably well. I mean, we could have added a few weights out there to make it spin a bit longer, but I'm happy with it. I'm really happy with that. Realign to match up, and the center knob should be smaller though. Well, I'm just going to leave that like this. Shit, if it would actually stand up. Why does it not stand? There we go. Okay. So, with that, I think we're done here. So we've got the perfect 7mm deep spinning tool. Something is, oh, that's the laptop speaker, something making noise. Okay. All right. I think that was a good experiment. So what did we learn today? We learned that OnShape's collaborative editing still isn't quite as good as we were hoping for. So I was hoping for just live updates, and I did try in a browser a minute ago. It's not working. It's not like super real time. So I will need to do that. I will need to figure that out with the OnShape guys. And yeah, I mean, this was really fun. You know, those things that are just really stress-free and more or less carefree too, because I mean, I wasn't trying to achieve greatness today, but I think we still got something done. That's the stuff I really enjoy, just, you know, hanging out, creating something practical, maybe getting a few people to print the stuff you design. That is awesome. But yeah, cool. All right. Right. Okay. I guess that's gonna be it for today. It is late-ish, and I'm tangled in filament. It is 9:53 here. Again, thanks. Am I even in frame? Oh, I don't need a head. Okay. Again, thanks everyone for being here, for joining in, for helping out with tips and tricks. This one was pretty loose. For making your own designs, for being along for the ride, and yeah. I guess that's gonna be it for today. Thanks for watching, and I'll see you in the next one, next video, next stream, next whatever. This thing could be a bit heavier, but I'm happy. All right, see you all, have a good night, and yeah, see you soon.